All right, so to this. Today, we're diving deep into a world where tough takes on a whole new meaning.
We're talking about space stuff.
Yeah. Like, seriously, imagine launching something into space.
Right.
It's got to handle insane temperatures,
Oh, for sure.
radiation dot forces that would turn a car into like a crumpled up soda can.
No kidding.
So how in the world do engineers make sure that spacecraft and satellites can actually, survive out there?
Well, that is the million-dollar question, isn't it?
It really is.
And to try to get to the bottom of that, we're looking at this case study from Infinita Lab about, well, a pretty specific test, the Izod impact test.
Izod impact testing.
Yeah,
Okay. See, now that sounds intense.
it is.
I mean, just the name.
Mm-hmm.
And this case study, right, focuses on a company that's working on a space project,
Oh, yeah.
like actual rocket science stuff.
Real deal.
So what was the challenge? Why did they need this very particular test?
Okay, so basically they were working with all these new materials, but the clock was ticking.
Ah, I see.
They needed to know, like ASAP, how these materials would react to a sudden impact. Think about it.
Okay.
Space debris,
Mm-hmm.
micrometeoroids, all that kind of stuff.
Right.
So this Izod impact test basically helps determine exactly how much energy a material can absorb before it just fractures.
Okay, so it's like a cosmic crash test.
Exactly. Yeah, think about those car crash test dummies.
Oh, yeah.
It's like that, but for the materials themselves.
Right.
So it tells the engineers, how much of a beating can a material take before it fails.
Makes sense.
Yeah.
But the source mentioned some things that kind of make me nervous, to be honest.
Oh.
Complex samples, budget concerns. This is starting to sound a lot like my last DIY project, which, well, let's just say it went way over budget and took about 3 times longer than I planned.
I've been there.
So what were the hurdles that Infinita Lab had to deal with here?
Right. Well, the materials themselves, they were pretty complex. So just preparing them for testing that was intricate, took a lot of time.
Mm-hmm.
And then, of course, having to do all of this on a tight budget, I mean, that always adds a whole other layer of, well, difficulty, right?
Oh, yeah, for sure.
So that's when Infinita Lab kind of comes in with this game changer, and they propose, hey, why don't we have the client prepare the samples?
Wait, really? That's
Uh,
interesting. Why was that such a big deal?
Well, I mean, think about it.
Okay.
Win-win, right?
Mm-hmm.
Reduces the cost significantly.
Yeah.
But even more important, saves a ton of time.
Oh, that's smart.
Right. And it's a perfect example, I think, of just finding solutions that actually benefit everybody involved.
Totally. And it paid off, too.
It did.
The source says, they delivered these accurate results
Yeah.
quickly. But I'm still kind of wondering, how does knowing, like, how much impact a material can withstand actually translate to a successful space mission?
Okay, so think of like a spacecraft's heat shield.
Okay.
It has to be able to withstand all those tiny, super fast space debris impacts without just like completely breaking apart.
Oh,
So knowing that impact resistance can really help inform like design changes, right? To make sure the spacecraft and everybody on board is safe.
wow. It really is incredible how something that seems like a pretty simple test can have such a huge impact on, well, on space exploration.
It is, and it makes you wonder, right?
Oh,
Well, if we can create these materials that are tough enough to survive, the crazy, harsh environment of space,
yeah.
what other things